This is a video from section 12.4 and it's based off the lecture notes. A matrix is a rectangular array of numbers. In example 1, we have the matrix 1, 2, 5, 7, 9, 8. And if you notice, the entries of the matrix are in the form or are arranged in the form of a rectangle. And so in this matrix, we have one row followed by a second row. And then we have 1, 2, 3 columns. So the size of this matrix is 2 because 2 represents the number of rows by 3, and the 3 represents the number of columns. And in the second example, we have the matrix 1, 2, 3, 4, 5, 6. And then in this second example, we have 1 row, 2 rows, 3 rows, followed by 2 columns. So this size of this matrix is 3 by 2 because there's 3 rows followed by 2 columns. And in the third example, we have the matrix 1, 4, 9, 5. That's a 2 by 2 matrix. And if you notice, we have the same number of rows as we do columns. And in the fourth example, we have the matrix 2, negative 1, 5, 3, 2, 7, 9, 8, 6. And that's a size 3 by 3 because there's 3 rows and 3 columns. We are primarily concerned with square matrices, and those are matrices that have the same number of rows as columns. The determinant of the matrix, and I can write this a little cleaner if you guys need. So the matrix here is A, B, C, D. Is the number AD minus BC. And so we take the entries along the main diagonal and multiply them. And then we subtract the product of the entries along the other diagonal. And that's where I'm getting AD minus BC from. And we write, this is in determinant notation, so we take the entries of the matrix and we put absolute value bars around those entries. And this tells me to take the determinant of the matrix A, B, C, D, and we get AD minus BC. Now let's look at the determinant of a 3 by 3 matrix. The determinant of the matrix A1, A2, A3, B1, B2, B3, C1, C2, C3 is the following number. So I'm going to take the first entry of the matrix. We're expanding around the first row the whole time when we do determinant of 3 by 3 matrices. Okay. Now I'm going to circle the entry in the first row, and I'm going to eliminate the row and the column that contains that entry, and I'm going to take the determinant of the resulting matrix, which in this case I'm taking the determinant of the matrix B2, B3, C2, C3. And then we're going to alternate signs. So we're going to subtract A2. And what we do is we're going to eliminate the row and the column that contains the entry A2. And then we're going to multiply by the determinant of the resulting matrix. And so we're going to multiply by the determinant of B1, B3, C1, C3. And then we're going to add A3. And then we're going to multiply by the determinant of the resulting matrix. And to get that resulting matrix, we eliminate the row and the column that contains A3. And so, in other words, we're going to take A3 and multiply by the determinant of B1, B2, C1, C2. And we write the following. So we're going to take the determinant of the matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. And that's going to equal A1 times the determinant of B2, B3, C2, C3, minus A2 times the determinant of B1, B3, C1, C3, plus A3 times the determinant of B1, B2, C1, C2. Okay, so after all that, we can do a couple of examples. So let's take a look at example 1. So if I want the determinant of 2, 3, negative 1, 5, okay? Now, I'm going to take the product of the entries along the main diagonal, which in this case is 2 times 5, and I'm going to subtract the product of the entries along the other diagonal, which in this case is 3 times negative 1. But this is 10 plus 3, which is equal to 13. That's example 1. Example 2. Suppose I want the determinant of a 3 by 3 matrix. So this one is 2, negative 1, 4, negative 5, 6, 2, 1, 4, 3. Okay? Now, 2 is my first entry. So I'm going to eliminate the row and the column that contains the 2, and I'm going to multiply by the determinant of the resulting matrix, which in this case is 6, 2, 4, 3. I'm going to subtract, right? We alternate signs. So we're going to subtract negative 1 times the determinant of the resulting matrix, which if I eliminate the row and the column that contains negative 1, I'm multiplying by negative 5, 2, 1, 3, that determinant. And then I'm going to add 4 times the determinant of the resulting matrix. But if I eliminate the row and the column that contains the 4, I get negative 5, 6, 1, 4. So if I go to the next page, this is equal to 2 times, I'm going to get 18 minus 8. And then I'm going to, subtracting a negative 1 tells me to add 1. And then I'm going to multiply by negative 15 minus 2, right? So I'll come over here, and I'm going to write negative 15 minus 2. And then I'm going to add 4 times negative 20 minus 6. So this is 2 times 10 minus 17 plus 4 times negative 26, which is 3 minus 104, which is negative 101. And that's going to conclude this video for section 12.4, and this is part 1 for the lecture notes. Okay, thank you.